Example 5.2, use the shooting method to approximate the solution to the boundary value problem of the elastic curve in a beam deflection of equation 5.8. So the equation is given EI d2y dx square equals 1 over 2 WLX minus 1 over 2 WX square. Okay, with the initial condition y0 equal to 0 and y10 equal to 0. Okay, so that is the equation 5.8. Let L is given 10 meter, E210, I 4.5730, W15, and a step size H equal to 0.2, and the boundary values of Y0, 0 and Y10, 0. Okay, so we will insert the parameter value into the equation. So your E is 210 times I W L X is X minus 1 over 2 W X square. So we will simplify this. It becomes 960.33 equal to 75x minus 7.5x square. So let's make the second derivative as the function. Means that we want to divide this. Okay, so we want to bring this to the right hand side, so that means that this right hand side divide by that value. Okay, so this is the second derivative, second order differential equation. So we want to solve this. Okay, we want to solve this, and the initial condition, we copy this y0, 0 and also y10 equal to 0. In other words, the value inside the bracket means this is where the starting value of x, and this is the end value of x. Okay, 0 to 10. So by using shooting method, remember we have to convert the BVP into IVP. Okay, how to do that? So in the first step, we introduce a new variable z as dy dx. That's it. Okay, this is the first step. You have to introduce another variable equal to dy dx. So your equation now consists of two first order equation, which is the first one is the one that you introduce. So we write as dy dx equal to z. This is taken directly from here. I just rearrange the position left to right and right to left. B, the second equation, is our value here. On the left is d2y dx square. This is actually dz dx. Why I say like that? Because you introduce z is dy dx. So if you calculate this, actually d2y dx squared, it is the same thing. So we replace to the first derivative dz dx, okay? And the right hand side remain the same. We just copy what it is. Now you have two first order that equation, okay? So for each equation, let's state the initial value, y0, and this one should be z0. y0 can be obtained from this setup, okay? It is equal to 0. For z0, you have to guess, okay? So let's take 0 as the first guess. This is what you guess. We don't know the answer yet. It's okay. After we do two guess, then we will employ extrapolation. During the extrapolation, we will get the exact value of the first value of z. So this is the first step, where you produce two equations with its own initial condition. The first one is just taken from the information, and the second one you have to guess. Okay, now now step number 2. Step number 2 is, let's use the first guess, which is our first guess is 0, and we want to solve this by Euler method. Remember, what is Euler method? It is xi plus 1 equal to xi plus h, yi plus 1 equal to yi plus f1h. Then we have z. Zi plus 1 is zi plus f2h. Now let's reformulate this one based on our case. Xi plus 1 is xi plus h. Remember, your h is given as 2. Yi plus 1 is yi plus f1. What is f1? F1 is this, and this is f2. Okay, so we copy what is f1, which is just z, so we put subscript zi times dengan dia punya times step 2. Zi plus 1 is zi plus, okay, what is your f2? So that's whole thing, the fraction of that is over this value. This is your f2. Remember to put subscript I on each variable. Multiply by the step size. So we will use this setup in constructing the table for the Euler method. So start from I, and then we have x. Remember, the first value of x is 0, and by increment of 2, step size of 2, so you have 2, 4, and so on. So when to stop? When it reach 10. So you have to continue until you reach 10, and then you stop the iteration. So your I consists of 5 iterations. Then you have to construct the column of y and z. Okay, now the first value of y is 0, and our first guess of z is also 0. Now you have to find y1. So at I equal to 0, you want to find y1, which is y0. So I'm using our setup this, right? Plus z0 times 2. So which is 0 plus 0 times 2, and the result is 0. So the second value of y is still 0. Now let's calculate z. z1 at the same iteration. Z1 is z0 plus 75 x0 minus 7.5 x0 square over this value times 2. Z0 is 0, okay, and x0 is here 0, okay, so this is 0 minus 0 over this value times 2. Your first value of z is goes to 0 as well, so you obtain 0. Now let's go to the next iteration, I equal to 1, where we need to calculate y2 based on the formula. Y2 is y1 plus z1 times 2. Y1 is 0 plus z1 is also 0, so y2 is still 0. Okay, don't feel demotivated, we just need to continue, and let's see what happened here. It's not 0 forever. Then put the value of z1. Z1 is 0 plus, now your x1 is here 2. So we have some value here. Okay, then you can calculate your z2 is 0.2499. Now you can put here in the table. So you will continue the process for I equal to 3, 4, and 5, and then you will complete this table. You need to complete this table. Okay, now lastly, what we want to look is at the last value when x equal to 10. Okay, so what you found here, y10 equal to 3.7487. Is it equal to our desired value? It should be 0. No, it's not equal. So that is the second step, and we will continue with the next step.